I am a geek. I like things, all types of computers and things like that. But in addition to being a geek, I'm also a big fan of cars. I like tinkering with cars. I like seeing how cars work and following lots of things to do with cars. So what I've done with this particular session is combine those two things together so that I can add computer power to my car. And that's what we're going to talk about during this session. So again, the first slide that I have to put up is the usual Oracle safe harbor statement. And I think, again, we're fairly safe that I don't need to worry about this because it's very unlikely that what I'm going to show you will ever become an Oracle product. To start with, let's talk a little bit about cars and computers, because they do actually go together quite well. So here is a picture of my very first car. It's a 1971 Mini Clubman. And it was a great car in that it was my first car. But other than that, it was pretty rubbish. It had no electronics in it at all. Well, it had a radio. And then somebody stole the radio, so it really did have no electronics in it at all. Everything was what's called electromechanical. So it had these things called points, a distributor, carburetor, drum brakes, dynamo, and then for luxury features, it had lights, it had a horn, windscreen wipers that worked sometimes, a fan that worked probably less than the windscreen wipers, and an ignition switch. So essentially, it was very simple from the design and what it had in it. So I actually still have the service manual for my first car, which I know is pretty pointless because I don't still have the first car. And my wife despairs of me that I keep these sorts of things. But it was interesting to put a picture of the wiring diagram for the car. As you can see, there's a number of circles which represent the different components, and lots of lines, lots of wires going back and forth between the different items. So that was the 1970s. Let's move forward to the current decade. And this is my current car. It's a 2011 Audi S3. This has lots of electronics. It has a computer that controls the engine. It has a computer that controls the brakes. So I have anti-lock brakes. It has some magic called an electronic stability program, which is designed to stop you from skidding as you go around a corner too fast. It even has some suspension that has fluid in it, which the viscosity can be changed by applying a magnetic field. So you can actually change the suspension settings electronically. And then it's got all sorts of other things. Even the throttle, where you press the accelerator pedal, is not actually connected directly to the engine. It has a sensor which sends an electronic signal to the computer that controls how much fuel gets put into the engine. So what do you think the wiring diagram looks like for this car? If the one for the first car was really quite complicated, this one should be terrible. But it's not. Because now, if we tried to connect all of those things using individual wires, it would be too much. Most of the car would be wiring. So to get around that problem, the car designers use a bus so that signals can be sent on the bus with an address. And this is very common, we use this kind of thing in networking, in computing. So if you want to send a signal from the switch on the dashboard to the lights. Rather than sending a wire between the two, the switch will send a signal saying turn on the lights to the control unit which controls the lights. And because of the different parts of the car, there's actually 3 different buses, or at least there is for Audi. There's what's called the convenience bus, and that controls things like the windscreen wipers, the electronic windows, the switches on the steering wheel, those types of things. There's the infotainment bus, which is the one that carries all the information from the satellite navigation system, the radio, the iPod connection, those sorts of things. And then there's the powertrain bus. This is the important one because this sends all the signals from the accelerator to the engine, from the engine to the other control systems, brakes, and so on. So having understood a bit more about how electronics work in cars, I thought I shall build a Carputer. And what I wanted to do was to display information. This is actually the Carputer that I built here. And we'll talk about what it is and how it works. So I built 2 versions of this. So let's talk about the Mark I, the first version. With this one, the idea was to have a screen in the car where I could display extra information as I was driving. What I wanted was to get more information from the car and all these sensors that were available and display that information so I could see different things as I was driving. I wanted to know how much power was the engine generating, how much torque was I getting. I was interested to see things like my driving. So what was the position of the throttle? Now, I know because I'm pressing my foot on it roughly where it is, but it would be interesting to monitor that. I also wanted to see the G-forces on the car, the acceleration in different directions. And I thought it would be nice to produce some graphs so that you could see as time went by how things were changing. This is the architecture that I used for the first version. And at the heart of it is a Raspberry Pi. Raspberry Pi is a nice, cheap, single-board computer. I'm sure many of you have heard about it. Many of you probably even own a Raspberry Pi. What I then connected that to was a touchscreen. And I used the HDMI connection. I had power coming from the car to drive it. And then I had an accelerometer, so I could measure the forces on the car. And in order to get the information from the car, in terms of the systems, I used this little box here at the top, which plugs in underneath the dashboard into a port which is used for servicing. And that connected via Wi-Fi. Now, this little box is something you can buy on eBay. It's called an ELM 327. And as I say, it plugs into the service port underneath the dashboard, and it allows you to read certain information from the car. It's really designed for monitoring if there's any faults on the car, and also when they want to test whether the exhaust gases are correct for your car. There are 2 versions that you can see here. One is a Wi-Fi version, and there's another one which is a Bluetooth version. I used the Wi-Fi one just because it seemed like an easier one to use when I started working with it. Took a little bit of setting up in terms of the overall configuration because it used ad hoc networking, and that meant that I had to configure the network correctly on Linux. Once you've done that, it's really just a matter of sending commands to the box across the network and then reading the response back. And it uses AT-style commands. And I don't know if anybody here is old enough to remember modems, but those used AT commands. So it's a similar kind of thing. It just says, read this value, and you get it back. The touchscreen that I used was one, again, that I bought off eBay. And it was designed specifically for cars. So it had a particular size of fitting, which meant you could put it in the dashboard if you wanted to. It had an HDMI input, which was good because that made it simple for the Raspberry Pi. And it also had a USB connection to handle the touchscreen. So again, that made it simple to actually get the information from the screen as well as sending it to be displayed. So this is the inside of the first version of my Carputer. And there's a couple of things to note here. One is the use of woodwork. Now, I'm a firm believer that all good software projects should involve woodwork. So I have succeeded there. The other thing to notice is that I had a little bit of a problem finding a short HDMI cable. So you can see I had a 1 meter cable that literally had to go about 5 centimeters. So I ended up with this big loop of cable going around the Raspberry Pi. I would say that I have since found a shorter cable that I use. The accelerometer was a board that you can buy fairly cheaply from SparkFun. And this is a very nice little piece of hardware because it has 9 degrees of freedom. What that means is it can measure acceleration in all 3 axes, so X, Y, and Z. It can also measure gyroscopic information, so the rate of rotation in all 3 axes. So you can actually tell when it's being rotated and how fast it's rotating. And it has a compass that again works in all 3 axes. So it doesn't matter what angle it's at, it can compensate and give you a correct reading. In terms of using the Raspberry Pi to communicate with this, you use what's called the I2C interface. And that's fairly simple to use. You use a thing called Pi4J to communicate from Java to an I2C device. So once you've decided what device it is, you can then write a little bit of Java code and read the information from there. I got the acceleration information and I got the gyroscopic information without any problem, but the compass seemed to be a bit more difficult, and it used a second I2C bus. And so I didn't really need the compass information, so I kind of left that. This is the kind of code you end up with. It looks quite sort of involved, but it's actually quite simple. Most of it's about knowing which particular numbers you need to send to the device in order to set various things up. One of the things you can do is you can decide whether to measure the acceleration in terms of 0 to 2g, 0 to 4, or 0 to 6g. So you can really throw this thing around and get results. I decided that for my car, I would go 0 to 2g. I figured if I'm doing more than 2g in any direction, I'm having some serious problems. So this is what we end up with, the ability to read the acceleration information. So then I set about thinking, how do I take the information that I'm reading from the car, that I'm reading from the accelerometer, and then display it whilst I'm driving? And the idea that I came up with is that I would have a sequence of screens. So you could switch between different screens to show different sets of information. What I didn't want to have was complicated displays. If I had lots of numbers being displayed, I wasn't going to be able to read that and drive safely. I also wanted to make sure that in terms of changing the screen, I used the simplest possible user interface. I didn't want to have pull-down menus and have to select sub-menus, again, while I'm trying to drive. So I thought, okay, I'll have a look at what other people do and use some inspiration from them. So this is a French car, the Renault Megane Sport, and there's 2 different versions of the display that they do. One is older than the other. And that shows you things like the turbo boost, the throttle position, what gear you're in, and the more modern one also gives you this nice little sort of image of the G-forces that you've pulled going in different directions. Then I had a look at this. This was a Tesla, which is the electric car that you can get in the US. And I've been in a Tesla a couple of times, and this is a really impressive display. It's about that big, and it sits right in the center console. And you can display all sorts of weird and wonderful information about the car. And then you can get really kind of out there. So this is the Lamborghini Revuelton. And you look at that and you think, is it a car or is it a spaceship? Because some of it, I don't even understand what it's showing me. So I looked at that and I thought, okay, I'm going to keep it simple. So what can I come up with as a display? This is what I came up with. I wanted it to be simple, and the other thing I wanted to do was to limit the amount of graphics that I was going to use so I didn't have problems with performance. So I thought a simple bar chart would be a good place to start. And by doing it this way, you actually only need a minimum of 3 nodes in the scene graph. That's the outer rectangle, the inner rectangle, which shows you the current value, and then I put a red line, which would show you the maximum value that you've got to in a particular run. Then you can add some numbers at the side so you can see the minimum and the maximum value. But the great thing about this is you can look at it very quickly and immediately get a sense of what the value is. You don't have to read a number, you can just look at the bar chart and see what's going on. So then I put these things together, and the first thing I did was I created a splash screen for my application, because I really wanted a nice splash screen. And for that, what I actually did was I photographed the infotainment system in my car, which is the bit in the middle. And then I photoshopped in the Java logo and Duke with the Raspberry to give me a nice Java-flavored splash screen. So then the first screen used my bar charts, and I show 5 different pieces of information. So there's the current load on the engine, and that's used to tell you when to change gear. There's the temperature of the air coming into the engine. There's the engine, the temperature of the exhaust, so what's coming out of the back of the car. There's also the throttle position and the fuel pressure, so how much the fuel is being injected into the car. Then I thought, okay, I want to show the G-force, and I used inspiration from Formula One. If you watch Formula One, you see these kinds of displays showing you how fast the drivers are going around corners. And so the concentric circles here represent, each one represents half a G. So right on the outside, you'd be doing 2G. And the idea is that as the dot moves up, that's accelerating forwards. As the dot moves down, that's when you brake, and so you're decelerating. Left and right, obviously, is the car as it moves to the left and to the right. And then the little line on the right-hand side shows the acceleration as you go up and down. Now, you wouldn't expect to do too much up and down, but obviously as you go over bumps, it will actually record information. So that was the first version, and I'll show you a demonstration of that at the end. Then I thought, okay, so I've managed to do all this. What I want to do is I want to create a version 2 of my application. And I want to add more information. So I set about looking at different sensors that I could connect and different ways of recording information. And this is the new architecture for the Mark II version. In the center, we've still got the same box that we had before. So there's a Raspberry Pi with the Wi-Fi dongle that talks to the same sensor to get the information from the engine. We've also got the accelerometer, but then we've got some other sensors. So I added a heart rate monitor. So I could actually wear a heart rate monitor as I'm driving, and then I could record my heart rate as I go along. I also thought it'd be interesting to add a GPS so that I could map the position of the car. Now, it's true my car has a GPS system in it, but trying to get the information from that was going to be very complicated. So I thought it's just easier to add another sensor. I added another Raspberry Pi because I really needed more USB ports, and it was actually easier to do that than to use a hub. And I connected some other things. So there's a thing that talks to the CanBus. That's the bus architecture in the car, which we'll talk about in a bit. I also added some temperature sensors, which we'll talk about. And I had an attempt at monitoring tire pressures, because you can buy from China these little sensors that you screw onto the valve caps, and then they send a radio signal. But I didn't actually get very far with that. I couldn't decode the information that I was getting in an accurate way. And then the last thing I thought I'd add was a video camera, so that I could have video showing what was happening in the front of the car. So let's talk about all these different things and how we use them. So the first thing was the GPS. And this is actually pretty easy to use. What you've got is a simple board that you can buy from Adafruit, and it will give you 10 readings of the position and the velocity every second. It has a serial interface, so it's pretty easy to connect. You just connect it to the serial port, and then you set up the right speed and the right parity and so on. And then you just use the librxtx Java library, and you can read data. What you get is a stream of lines of text, which you then need to look for particular keys to represent that that's the position that's coming from the sensor, or it's the velocity. One of the things I noticed is that you do tend to get quite a lot of corruption of the data for whatever reason. So all you had to do there was to just detect if there weren't enough fields in the result that came back, and then if there weren't, throw that away and read it again. But it seemed to be easy enough to get around that. Heart rate monitor. So this is another little board that you can buy. This one's from SparkFun, and this has a USB interface. So it's kind of like a serial connection. Use the same library, set up the same speed. A little bit more complicated in terms of the coding, because rather than just getting a stream of data, you actually have to send a command to say, give me the current reading, and then you get the reading back again. So that wasn't the problem. What I did find, though, was when I originally fitted this in the Carputer, I actually put it behind the Raspberry Pi. And that caused me problems because the range over which it would actually work was quite short. And if you started putting electronics between you and the sensor, it wouldn't reliably read the signal. So I fixed that by putting it in a separate box and then just having a USB cable so I could put it nearer to me, and I got a reliable reading. In-car video. Now this is something that's become very common over the last couple of years, because people like to put cameras in their cars that can record what's happening in front of them. So if they're in an accident, there's evidence to show that it wasn't their fault. Really, it wasn't their fault. And so I bought one of these, and I found one that I liked the look of because it had a Wi-Fi connection. I thought, great, I can use the Wi-Fi connection, and then I can read the data from the camera, and I can store it along with the data that I'm reading for the rest of the car. Bizarrely, this comes with an iPhone app. So you can download the app, and then you can watch the view from the camera on your phone. Don't know why anybody would want to do that, because the range of the Wi-Fi connection is very short. So if you're watching the video of what's happening at the front of the car, you would be in the car. So if you're in the car, why would you want to look at what's outside the car on a screen? But anyway, they have that. So then I thought, okay, I want to read the data from there. How do I do it? And I went through a number of different approaches. First of all, I tried contacting the technical support people for the company that make the camera, and I asked them if they would give me the details of how to read the data. And they said, no. Okay, so then I started doing some, like, not exactly hacking, but I started doing a port scan to find out which ports were being used. I then started looking at, there's a program called Wireshark, which will literally listen to all of the packets that are coming across your wireless network and show you what those packets actually are. And I got to the level where I could understand that it was using RTSP, real-time streaming protocol, to send the data. But you had to set up like a communication handshaking thing before it would work. And then you get into all these SYN and ACK packets. And I thought, no, that's too complicated. I don't want to do that. So I thought, okay, what do I actually want to do? I want to synchronize the video with the data that I'm reading from the car, so that when I play it back, I can have the video and I can have the data at the same time. How do you synchronize video and audio? We've been doing this for a long time in the film industry, and it uses a very, well, essentially simple piece of equipment. It's called a clapperboard. And so we often see people in films, you know, when they're making a film, they say scene 1 and clap. And the idea of that is it gives an audible signal on the soundtrack. So when it's being recorded, you know that's where the audio starts, and you know that's when the video starts. So I thought, I shall do the same. So what I did was I added a button to my box. So the idea was, with that, I could hold the button down when I started my application. I had a piece of cardboard, which I stuck in front of the video, and then at the same point that I removed the cardboard, I'd release the switch. That would start the recording, and I knew when I watched the video that where the cardboard came away from the video, that's where my video started. And it seemed to work. So then I thought, Formula One, this is exciting. How about we do something like this? And this is the kind of pictures that they show you in Formula One to show you how hot the tires are when the car's being driven. I thought that'd be great, I'll do that. What I discovered is that Formula One has a lot more money than I do. The cameras that give you these kinds of pictures are very expensive, really expensive, like literally thousands of dollars. And I don't have that kind of money for my project. So I looked around and I found that there's a sensor that you can buy, which is an infrared thermometer. So effectively what it will do is read the temperature of something at a range. So you don't actually have to put it in contact. It uses the infrared radiation and tells you what the temperature is. I then found that by connecting that to another little board, which is it's called FTDI, that turns it into a serial connection again. So it's easy to read the data from it. And I ended up with this. And I thought I'd use this because if you were in my session this morning, where I talked about lambdas, well, this afternoon I should say, I talked about lambdas and streams. This was an example of how you can use them. So I had this method that executed in a separate thread. And what I did was I set up a buffered reader to the serial port that was returning the data. And the data that comes back is in the form of strings. But the strings are in Fahrenheit, this funny scale that the Americans insist on using, and they had a capital F at the end of every line. So I came up with this, where I used a map to double. So I took the lines, which is the stream source. I had map to double, so I could then parse the string, having removed the F, into a double value, keep it as a primitive, and then map that using a conversion from Fahrenheit into Celsius. So now I've got the temperature in Celsius. And what I wanted to do then was to only do something if the temperature had changed. So rather than processing the same temperature all the time, only if it changed, do something. So we filter out where the temperature is not the current temperature. And then I pass that into a nice little method called peak. And what peak does is takes the input stream and passes it directly to the output stream. But it allows you to look at it as it goes past. So in there, I could then use an optional, which I talked about this morning, and say if that optional is present, this is a listener, so if the listener is present, report that the temperature has changed. And then to terminate the stream, even though it's an infinite stream, we have a for each, and we simply set the temperature to be, or the current temperature to be the temperature. So I wrote this code, I compiled it, I ran it, and it worked. I thought, great, my code works. I like it when my code works. And then I thought about it a bit more, and I thought, but that shouldn't work. That actually is wrong. Why does it work? And the reason that I thought it was wrong is because I'm referencing current temperature, which is non-final. And I'm trying to change the temperature in a lambda expression. And it's the same thing with anonymous inner classes. You can't modify variables from the surrounding scope. So I did some digging into this, and I discovered that actually what's happening here is that the compiler does a little trick on your behalf. And it adds a this for you. So in the lambda expression, what actually happens is that rather than saying current temperature equals T, it says this dot current temperature equals T. And then because this is effectively final, we can then reference the current temperature through that, and our code works. Just an interesting aside. Then we had to fit the sensors to the car. So I had two sensors, and I thought one to monitor the tire temperature. So I kind of clamped one of the sensors under the wheel arch so it was pointing at the tire. And then the other one, I found there was a nice little suspension bracket in the car. So I clamped onto that and then mounted the sensor on there. So it was pointing at the back of the brake disc. And you can see there, there's the brake disc and the sensor. That way, I could check the temperature of the brakes as I'm driving around. And when I first did this, as I say, I had a second Raspberry Pi, which was connecting to the sensors. So I put it under the bonnet of the car, because that was the easiest place to put it and have it access to the sensors under the wheel arch. So you can just about see there's a small black box in the middle, which is the Raspberry Pi. And then I set it up so it had a simple server on it that could connect over the network, and then I ran a network cable from under the bonnet through into the car and connected it to the Raspberry Pi. All very good. However, what I discovered is that putting a Raspberry Pi under the bonnet of your car is not a good idea because it gets very hot. So the internal combustion engine generates a lot of heat. And so this is after 10 minutes of driving, the Raspberry Pi was up to 50 degrees Celsius. If I'd left it under there for much longer, it probably would have melted. So I needed a different approach to that, which was essentially just to put some longer USB cables from the sensors and put those into the car and leave the Raspberry Pi in the car. Now, what I really wanted was all of this lovely information that's flowing around these different buses in the car. And in theory, I should have been able to get that from the little box, the OM327, because that has wires which are connected to the CanBus. When I tried to do that, I found that I wasn't getting any data. And I tried and I tried, and I couldn't work out. I tried different boxes, different connections, didn't work. Eventually what I decided was that it's actually the manufacturer, Audi, have turned off all that information coming through that port, which in a way makes sense because it's designed to stop you from hacking the car. And that's not just me hacking the car, it's people who could potentially override security systems in the car. So Okay, I said boo, but the idea is that we want to get the CanBus. So I had one rule about this project, and the rule was that I couldn't modify the car, because strictly speaking, the car's not mine. It's a lease car. I almost succeeded. When I looked under the bonnet, I found there was part of the wiring loom, and doing a bit of research on the internet, I found the colors of the wires, which are the CanBus. So I very carefully stripped back some of the insulation on the cables, wrapped a new wire around it, and you can see there I've got my connector, which connects to the CanBus. And I connected my oscilloscope to it, and behold, I had a signal, success. And what was even better, the car still worked. Because I was a bit worried that I was going to break my car, but it still worked. So then, that's only part of the problem. That's just the electrical signal from the CanBus. So I have this device, which is, what's it called? It's a lower cell CanBus to USB. And so I plugged that in, connected it to the CanBus, and I could actually get data from there. But that's only part of the problem, because one of the things that Audi don't do is publish a nice list of all the commands that are being sent on the CanBus. So you have to kind of reverse engineer everything. And I must admit, I haven't got around to doing that yet. So this is the finished version 2. So there's a bit more wiring in there. You can see that I did find a shorter HDMI cable. And then this is the box in the car with various different bits and pieces connected. And you can just about see the video camera at the top. So then I thought, okay, so I'm going to record all this information. And this time it was more about recording than showing the data as I'm driving. And I thought, right, I shall write a JavaFX application that will display the video, and then it will display different data as you watch the video, so you can see what was actually happening. It's pretty easy the way that it worked in terms of the data. I just stored everything as one line of text per sensor, per reading, and then each value is comma separated, and it's pretty easy to read. Originally, I thought I'd have a nice little progress bar chart as I read all the data, but I found that if reading 15 minutes worth of data takes about 100 milliseconds, so you don't really need a progress bar chart for that. Lots of different things that we can display. So, all the usual things like the G-forces, the GPS coordinates, the temperature of the tires, the brakes, the coolant, the catalyst, all sorts of different things, and the heart rate, of course. So before I show you the demos, because I've got about 10 minutes, that's good. Before I show you the demos, let's just a couple of conclusions. Cars are really all about data now. What you see more and more is computers taking over in terms of cars. There have been numerous examples of things like Google, who do a self-driving car. There was a car that drove across the US just the last couple of weeks, completely autonomously. It did have somebody sitting in the driver's seat, so it wasn't dangerous. Audi did a nice demonstration of a car driving around a racetrack at absolutely flat out speed. You couldn't get it to go any faster because it was able to measure everything. So we can collect a lot of this data, and then we can play it back. And playing it back actually does have some real world uses. Insurance is a good one. So certainly in the UK, they're talking about adding what is effectively a black box to a car so that they can monitor your driving and then base your insurance premium on how you drive. The better you drive, the lower your premium. The worse you drive, the higher your premium. We can use it for things like fleet management, even driver training, all of them very good uses. Java is a great way to get all this information and then have it played back. So, oh yes, and there's just a few links here for places. So sparkfun.com, adafruit.com, which is where I got most of the sensors from. raspberrypi.org, which is the place where you can get lots of information about what the Raspberry Pi does, how it works. I've written some of this up on my blog. I need to get around to writing up more of it, especially with the Mark II version. And then I also do things on Twitter and talk about some of this stuff as well. So let's switch to the other laptop now if we can, please. Oh. Okay. Oh, there we go. Yep. Is that all right?
This is slow. Thank you.
Okay. Yeah. Ah, good. Okay. So we can see the screen on there. Now, what I'm going to show you first. There we go. This one. So this is effectively going to be a replay of the version 1 of the car. So I recorded the data again just to make it easier to, because if I try and show it to you on this, you can't really see it from the back. And effectively, this is just showing you the same thing that we would have in the car. And then it's very simple to change screens. You just touch the screen and you move to a second one. So this is one I didn't show you. This is the advanced data. So it's throttle position, engine speed, and then a calculated torque and power output. And then we've got the G-forces, so you can see as you're driving along, we're going around corners and accelerating and decelerating and going up and down a little bit on the right-hand side. It seems to be about half a G, which is it's reasonably good. And then I thought, have a graph. So this is the throttle position. You can see most of the time I'm fairly restrained driver there. And then occasionally, oh, there we go. I'm accelerating quite hard there. And then also the power output. I think the scale on the graph for this is not quite right, but you get the idea of what it's showing. And then the last screen I had to have was a big exit button, because that was the only way I could actually get out of the application, because otherwise I didn't have a keyboard connected, so it was just had to have a big exit button. Right, so then the other one that I want to show you is the second version. And so, as I say, the second version basically recorded all the information, and I took the video from the camera, and then I've combined it all here. So what we're looking at here is the top part's going to be the video, but remember it's got a piece of cardboard in front of it at the moment. The bottom part is a map, so I can use Google Maps to show the position of the car. That's actually not connected at the moment, but will be in the future. Then we've got things like engine load, fuel pressure at the top. I've got the heart rate, so you can see what my heart rate is as I drive. Display in the lower right-hand corner is position of the throttle, the engine RPM, and if I get around to getting more of the information from the car, it will get out of neutral. At the top, I've got a nice set of LEDs, again, for the Formula One style of thing, so you can see the engine as it accelerates. And then we've got various temperatures on the left-hand side. So if I start playing the video, what you'll see is, first of all, we've got the heart rate going there, a little animation for that. And then you see the video sort of starts up and off we drive. Driving on the left-hand side of the road, which is correct. And then you can see also we've got the G-forces being displayed there as well. You can see what's happening with the different values. You can see the fuel pressure and so on. There's also the GPS coordinates coming up and which direction you're going in relative to north. And you can also skip forward so you can see other bits of the drive. But clearly that's it's very much the same thing. And then the other thing that I thought I'd do was to create some graphs of some of the information over the entire drive. So if I look at throttle position, for example, that shows you the throttle position for the whole drive. And again, that's kind of interesting to see how you use your right foot. And just one last thing was to show the heart rate as we graph that. And as you can see, my heart rate was fairly stable, although at one point something interesting happened. and it went up a bit. And then at one point, I got very relaxed, so it dropped off a bit. But again, it's interesting to sort of be able to see the historical data as you're watching the video and so on. So that's really all I have to show you with this session. I hope you enjoyed it, and domo arigato.